Now the way you are going to do the selection, that will matter a lot. For example, let's say this is vertex 1, 2, 3, 4, 5, 6. 6 vertices are present. Now if I have selected this in this way, if I selected this as the first vertex, this as the second, third, fourth, fifth and sixth, the location of the vertices are same, but the sequence of selection is different. So it will fit these nerves. Or same vertices, but I am going to do a selection in different way, definitely it will fit the different nerves. So the first and the last vertex will be the end point of the nerves, and in between it will always pass that curve through the points which you have given. So sequence for creating nerves curve, sequence will matter a lot, and the geometry of the nerves curve will change based on the sequence which you have given. This is the two methods which are available. One is interpolate and other is approximate. What interpolate does is, interpolate always passes that particular nerves curve through the points that you have selected. It always passes that nerves curve. Approximate does it, there is, I mean, you are not going to put a very stringent constraint that the nerves has to pass through the interpolation points. So what it does is like it allows the nerves to be created, it allows that nerves to be deviated from the points which are given. Those points are also called as control points. So it allows that nerves to be deviated from the control points. Now the how much deviation that you want to give, that can be provided here in the tolerance. So if you go here approximate, you can provide that deviation allowed in the tolerance, because most of the time if the nerves is very complicated, it will be difficult for a gambit to pass that nerves through all the points. So we can approximate it or give some available tolerance, allowable tolerance using this particular value. So this is about nerves curve in gambit. The another method of creating edge is by sweeping a vertex, and for sweeping we can sweep the vertex by giving along the given vector, or we can sweep the vertex along given edge. So what it needs is, it needs one or more real or non-real vertices, but it is going to always create a real edge. So sweeping operation always creates the real edge. So we can give one or more real or virtual vertices, or one or more real edges as the path. So that is what we can give, or we can give edge as a path. So what it does is, for example, if I have vertex, for example, let's say imagine that I have this vertex and I want to sweep this vertex in a particular direction, and let's say that direction is x. So I can always create that edge. So go to sweep vertex. So select the vertex which you want to sweep. You can select more than one vertices at a time, so it will create more than one edges at a time. So you can select that vertex and then a vector along which you want to sweep it. So in this case the vector direction is defined something like 0 0 0 to 0 0 1. So this is definitely, the direction is z axis and the magnitude is 1. I want to change it, let's say I want to sweep it to x along x axis. So I will go to define vector form, then I will say positive x, and definitely I am interested in the magnitude because I want to sweep it by 10. I will say apply. If you see, vector is changed, the start point is 0 0 0, the end point is 10 0 0. So it is in x direction and the magnitude is 10. So I will say apply. If you see, I got a edge whose length is 10, and for sweeping purpose it has used the x vector, the vector which is in x direction, and the magnitude of that is 10. Similarly, I can say same vector I want to sweep it in y direction. Same vector, I will go to define, I will say positive y, magnitude should be 10, and apply. What I got is, I got a edge in this. Or similarly I can say in z direction, select this vertex, define positive z, the magnitude should be 10, I got a edge in z direction also whose length is 10. This is one way of specifying the vertices and the vector along which that vertex will be swept. I can always specify more than one vertex at a time. So what I will do is, again I will use this vector along a vector. So this vertex and this vertex, if you see here, it is asking you vertices. and again define vector positive x direction 10. Now for every vertex it will create one edge. If you see, it has created one edge for this vertex as well as this vertex. So I'll just delete this curved edge, nerves curve, which you have created in last operation. So what I got is these two vertices. Similarly, I can say sweep. I want to sweep this and this vertex, or this vertex and this vertex, and I want to sweep it in positive y. Magnitude should be 10. Apply, and I'll say apply. If you say, I got different edges. So this is the way we can create the edges by providing vertices. Now I can always create a edge by providing edge as a sweep path. So what it does is, the direction of the sweeping will be decided by the direction of the edge, the way the edge shape is changing and the direction is changing, and the magnitude of the new edge, the length of the new edge, is going to be decided by the length of the edge which you are used for sweeping purpose. For example, I can always sweep this vertex, for example this vertex, and now I will say along this edge apply. If you see, I got one more edge which is of similar kind. The length of this edge is decided by the length of the edge which you have selected for sweeping purpose, and the direction is changing, and so definitely the new edge direction will also change. So again I will select a vertex, the path is edge, and then I will select the edge. If you see, it has also shown direction and everything, and I will say apply. It has created this. So if you see the direction, I'll just delete these two edges. If you see the direction of the edge which I am selecting as a path, this is the vertex which I want to sweep, and this is the edge. If you see the direction is shown somewhere here. The direction right now is this direction. So definitely after sweeping, what we get is, we get this edge, but I can always reverse that direction, in the sense I can say again same vertex, this edge, and I will say reverse it. If I say reverse, if you see, the direction is reversed, and if I say apply, what I got is, I got this edge. So this is the way this edge path will work. So you select the vertices, you can select more than one vertex as usual. So I will select this vertex, and this edge as the direction, apply. I got two edges. So this is the way the edge can be created by sweeping operation. The next operation is revolve. What revolve does is, it creates the real circular arc edge or a helix. It also creates helix. It always creates the real edge, and what it needs is, it always creates real edge in the sense, even if you have selected a virtual vertex, what it does is, it creates the real vertex at the same location, and then it does the revolve operation. What it needs is, it needs one or more vertices to be revolved. It needs the axis of revolution, which will be a general vector definition form, and it needs the angle through which the vertex are revolved about the axis, and optional is, you can also provide the height of the helix. So this is the revolve operation. This is the axis of revolution you have provided. This is the vertex to be revolved, and this is the theta angle to be revolved. So it will do this revolve operation, and you will get this particular edge. The effect of height will create a helix. So at the time of revolution, if the height is 0, it will be in the same plane. But if you see, at the time of revolution, if you have provided some height, so this height is nothing but the difference between the end point of the edge which is going to be created and the vertex which you have given for revolution or revolve operation. So at the time of revolution, what it does, it also increases the height. So this is nothing but a helix that you are going to create. So again I will do, I will delete all the edges. I want some vertices only, or maybe I will say reset, go to the famous graph paper, say apply, which will allow us to create the vertices very easily. So I will say okay, I want one vertex here, and again visibility should be off, apply, close. Now go to geometry and revolve operation. So what it asks is, first is it asks which vertex. So let's say this vertex, with what angle, let's say angle I want 180 degree, and this is nothing but definition of axis. Again, that is a general vector definition form. Now let us say axis of revolution should be y, so positive y. Now as it needs only axis, the magnitude will not play any role in this operation. So I can say magnitude is 1, or I can just deactivate it. In that case, by default the magnitude will be 1. So the start point is 0 0 0 of the axis, and the end point is 0 1 0. It means it is in positive y direction. If I say apply, what I got is, I got this particular edge, which is by revolve operation. Again I will select this vertex, I will say angle I want is, in this case let us say 360, define axis, positive y, magnitude doesn't matter, apply. What I got is, I got a full circle because I have given 360 degree after revolution. Similarly, what you can do is, you can always provide the height. So again, in this vertex, angle should be, for example, let us say I want only one revolution, 360, axis is let us say y again, and the height is let us say 3, and I will say apply. If you see, it has done one revolution, but what it has done is, it has increased the height. This height difference is actually whatever the height difference I have given. Now again I will select same vertex, and let us say I want 2 revolutions, and let us say I want 2 revolutions, so 720, height should be 3, apply. So what I got is, I got 2 revolutions. So this is the way you can create helix using this revolve operation, and this is the effect of this height. Another operation that you can do is, another way you can create edge is, you have one existing edge, you can create a new edge by projecting it on an existing surface. So this is nothing but project edge on a face. So it creates the real edge. Shape of any edge created follows the contour of the target face. So this is called as target face, this is called as edge. If you project this, one new edge will be created, a shape of that will be defined by the shape of the face. So there are different operations that you can do at the time of projection. You can say, okay, split a face or something like that. So projection of the edge extending beyond the boundaries of the face, what will happen to that? In this case, if you see, this is the face. If I am going to project this edge on this face, some part of this edge is going to be outside the boundaries of the face. So what it does is, it trims that particular edges. It means it will delete that particular edge, and only the projection edge is remaining there. So there are two methods of doing projection. One is closest distance, the direction of projection in fact. One is closest distance, and other is in a specified direction. Closest distance, what it does is, projects each point on the projection edge onto its closest point on the target face. The projection in the direction normal to the planar surface. So the projection is always normal to the planar surface, and direction is nothing but, if you have provided a particular direction vector, in that direction the projection will be done. So this is the effect of providing the direction or projection direction. So this is one edge. So if you have provided the direction option, in this case let us say we have provided negative y, the projection is done in this case, but when you say closest distance, the projection is done normal to the surface. So this is the effect of projection. Similarly, at the time of projection, after projection there will be new edge which will be created. Now the effect of the new edge will be different depending on whether the edge is completely intersecting the face or not. Now if I activated the split face option, now and if the edge is completely intersecting the face, then definitely one face will be divided into two faces after doing a projection. But if the edge is not completely intersecting the face, what it will do is, it will create something called as dangling age. It means this face will not be divided into two faces because there is not complete intersection, but what it will do is, it will just use this face, it will make this edge as a part of this face. It will do some splitting, but only one face is there. So this is called as dangling edge, and generally in geometry we don't want to have any dangling edges, because unnecessary it will put some constraints for meshing. So we will see that part in meshing. So we can always clean this dangling edge. There are automatic cleanup operations in Gambit available which can clean the dangling edges. So the point here is, if the edge is intersecting completely to the face, it will divide it into two faces. If the edge is not completely intersecting the face, it will create the dangling edge. So this is the method, or this is the form for face. So if you go to this, edge creation and project on face. So, you have to select the edge, you have to select the face, you have to select the method by which you are going to do the projection. So, closest distance does not ask you anything, it always calculates directions automatically, normal to surface in fact. And if you activate direction, you have to define the direction, and again that is a general vector definition form. So, you have to, in this case again the magnitude will not matter, only direction will matter. So, you can provide the directions by different methods which are there. Provide the direction and then activate if you want to split the face or not. If you do not activate split the face, only one edge will be created, and after that you can use that edge for some other purpose. So, that is nothing but create a edge by projecting on a surface. So, these are the methods available in Gambit to create the edges. The first method we have seen is the straight edge. You provide the 2 points, it will create the straight edge between these points. You can provide more than one vertices, so the 2 vertices will be consequently joined by 2 or 1 real edge, or you can provide virtual also, you can provide a host also in this case. The second method is arc, which is nothing but circular arc. So, there are different methods, center point and 2 point method, major and minor, you have to definitely select that. Then 3 point method, and then the radius, start angle, end angle, and if you want you can also provide the center. So, this is the method by which you can create circular arc. Another method is create a full circle. So, you provide center point and 2 points on the circle, or you provide 3 points on the circle, you will get a full circular arc. Then ellipse, you can provide the center point, you can provide the major, or you can provide on edge, and start angle and end angle, what you get in between is nothing but elliptical arc. Or you can provide, you can create the conical arc, you provide the start, shoulder point, end point, you provide 0.5 parabolic, 0.4 elliptical, and 0.6 more than 0.5 will be hyperbolic. So, this is the way you can create conic arc also. You can also create fillet between the arcs, you provide 2 edges depending on what is the value, or depending on what is this u value, or depending on where you are doing the selection, the edges will be created. The fillet arc will be created of this radius, and you can also activate the trim edge. The another method of edge is nothing but nerves, third degree, with natural boundary conditions. So, provide the vertices, it will fit the curve which is passing through that particular vertices. Next method is sweep vertex along a edge, or maybe you provide the vector. So, this is the method of creating edge by sweeping vertices. You can provide, or you can say revolve vertex. So, it will revolve the vertex in given angle along the axis which is given. You can also provide the height in between, which will create the helix kind of edges. Or the last method is you can create the edge by projecting it on a surface. 2 methods are available, closest and direction. If it is direction, provide the direction, or you can also activate the split face at that time. So, these are the methods which are available in Gambit to create the edges. So, let us have a look at another operations which are there on a edge. This is the operation which is connect disconnect. I guess we have already seen this operation in general modeling, geometry modeling operations in Gambit. We have already seen this. So, this connect operation does what? It connects 2 edges, and it in fact it connects faces and through edges. So, it means if I have 2 faces, for example, I will create a rectangular face of 10 by 10. I do not provide any other dimensions, so it will be by default 10, fit to screen, front view. Then again I will move copy. So, I will say this one, I want to copy this at exactly at location 10. Apply. Now, if even if you see that these 2 faces are connected, but right now they are not connected, it means although they looks like connected, they are not connected. For Gambit, connected means they should share some entities, lower order entities. Now, for face, the lower order entity is edge. So, if there is a edge common between these 2 faces, then and then only they are connected. So, right now they are not connected. If I go to this, and if I say summary, or I can say query, or in fact I will do a summarize, and then I will do a window selection, sorry, this is actually selecting wherever that window boundary is touching, it is selecting all the entities. I don't want completely enclosed, so I will go bottom to top. So only these things are selected. But if you go to pick list form, if you see there are two edges at the same location, edge 2 and edge 8 are located at the same location, so they are not connected. If you go to summary, if you go to summary and if you say okay, select edge 2 and say apply, if you see edge 2 is connected to face 1, which is probably the first face which I have created, and edge 2 I don't want edge 2, I want next entity at the same location, so I will do middle click. So middle click is edge 8, apply, and if you see that is connected to face 2. So although it looks like they are connected, they are not, because this face edge 2 is the boundary of this face, and for this face edge 8 is the boundary. Now I want to connect them. Because why I want to connect them? Because I want to have a conformal mesh. I don't want to have any gap, that is the first case, and I want to have a conformal mesh. So that is done through connect edges. So I will say connect, and now there is no gap in between these two edges, it is like 0 gap, so which is less than 10 raised to minus 6. So definitely I can do a real connect. So what I will do, I will select these two edges, this is the first edge and this is the second edge. I will select two edges, I will activate real connect operation and apply. So if you see what it does, it deletes one edge. So what it has done is, it has deleted edge 8, it has deleted edge 8 and it has done that reconnection. So what it does, connected vertex 2 to vertex 5, which is deleted. So definitely if I am going to delete the edge 8, two vertices will be deleted. So I have to also do a vertex connect operation, it means I have to also connect the vertices. So connected vertex 2 to vertex 5, which is deleted, connected vertex 3 to vertex 8, which is deleted, and connected edge 2 to edge 8, which is deleted. It means all the connect operation, what they does is, it deletes all the entities, in the sense it will keep only one entity there, it will keep, in this case it will keep only one edge there, it will delete all the duplicate edges, and then it will reconnect the remaining faces with that particular edge and make sure that only one edge is there and that edge is common between the faces. So in this case, now if I go and say summary, if I go and say summary of this edge, if you see now that edge is connected to two faces, face 2 and face 1, it means that edge is common between the faces, so they are connected to each other. So this is nothing but the connect operation, and in this case we can do real connect because they are in the proximity of 10 raised to minus 6, that is why we can do real connect operation. Now again I will delete this face, I will delete this face, sorry, go to face, delete face, I will delete this face, I want to delete this face, I want to delete lower geometry also, apply. So I got this face, again I will copy this face, again say sorry, move copy operation, this face I want to copy it. Now I don't want to copy it at 10, for example I will copy it at 11. So definitely there is a gap in between, and this gap is more than 10 raised to minus 6. In this case in fact the gap is 1. So I cannot do real connect operation. Real connect operation is impossible in this case because Gambit looks for 10 raised to minus 6 tolerance. So as the tolerance is more than 10 raised to minus 6, I don't have any other option than connecting them by virtual operation. So again still I want to connect this because I want to have a watertight geometry, I don't want to have any gap. So I want to connect them, so I can go to edge connect, the faces are connected always through edges. So edge connect operation, I will activate virtual forced, I will select these two edges, I will select this edge and this edge, I will say virtual forced. What virtual forced will do, it will not care about the gap in between, it will always do the connect operation. So I will say apply. If you see, it always does the connect operation, and the entity which is created is the interpolant virtual entity. It means the shape of that and the location of that new virtual face, or sorry, new virtual edge which is created, that is interpolation between the two edges. So again this and this, virtual forced, apply. As such this edge does not have any representation, mathematical representation, it always relies on the underlying two real edges for its definition. But we have done our own job, in the sense we have closed the gap, our geometry is a watertight geometry. So that will suffice our purpose. Now similarly I can do a edge connect. Virtual first, as I said, it will not care about the gap, but now imagine that there are 1000 edges, and let's say you are defined that 0.5 is a gap. I can tolerate 0.5 gap, but if the gap is more than 0.5, then maybe I have to have a look at that particular gap, and maybe I need to create a new geometry, because more than 0.5 is not actually a gap. Some surface is in fact missing there at the time of import. Something has happened and that surface is missing. So I don't want to just close the gap, I want to create a new face there because the gap is large. So in that case, what I can do, I cannot go to 1000 edges, I cannot see what is the gap in between. I want to do this automatically. So what I will say, I will say virtual tolerance. So I will again select these two edges, I will specify what is the gap to me. So in this case, let's say 0.5 is gap to me, more than 0.5 I am not evaluating it as a gap. So say apply. So if you see, it has not done a connect operation, because the gap that you see between these two edges is more than 0.5. So it will not do the connect operation. Similarly, what I can do is, let's say there are, as I said, 1000 edges, I will select all the edges, and now I will specify one is gap to me, and I will say apply. Still it is not done a connect operation, because this gap is more than, the tolerance should be more than the gap. Again all the edges and say 1.1, and I will say apply. Now it will do a connect operation. If you see, it has done a connect operation. So this is the way I can control the kind of connect operations I have to do. So virtual tolerance is nothing but you provide a tolerance. If the gap is less than tolerance, it will do a connect operation. If the gap is more than tolerance, it will not do the connect operation. And there is another way of giving the value of that gap, that might be in terms of percentage of shortest edge length. So what it will do, it will go in the whole geometry, it will search for what is the edge whose length is minimum, and it will calculate that L minimum length, and let's say 20% of that minimum length will be your gap value. So that is nothing but percentage of shortest edge length. So this preserve first edge shape is nothing but, if you see, if you talk about virtual connect operations, always by default it creates something called as interpolant entity. It means this, if I select this edge and this edge, if you see the location of the new edge which is going to be created, that is always interpolation. So this is always the interpolation. But if I want to preserve the first edge location, so I can activate preserve first edge location. This is the first edge which I am selecting, this is the first edge which I am selecting, this is the second edge I am selecting. So what it does is, it doesn't alter the location of the first edge, it does only this extrapolation. So I will say apply. So if he has not altered the Gambit has not altered the first edge location. Excuse me. So Gambit has not activated first edge, altered the first edge location. This is nothing but preserve first edge location. So virtual tolerance again, or this real and virtual tolerance, many times this is useful because we want to have real geometries as much as possible. We want to have real geometries, because some operations like split operations and all, they work on real geometries very well. So if we are going to select all the edges, and if we are going to say okay virtual tolerance, maybe it will create all the virtual entities, but it might happen that in that geometry there are some possibilities that you can do a real connect operation. It means there are edges which are in the proximity of 10 raised to minus 6, it might be possible, right? So what we can do is, we can say real and virtual tolerance. So what Gambit does is, it does real operation or it does real connect whenever the gap is less than 10 raised to minus 6. It does virtual operation whenever the gap is between 10 raised to minus 6 to the tolerance value that you have provided, and it will ignore the connect operation if the gap is more than the tolerance value you have provided, and that is done through this real and virtual tolerance. So this is one more operation available in real and virtual tolerance. So this is what the connect operation is done, and this is the connect operation or connect edges form. You can also do a disconnect operation. It means if there are some entities which are connected to each other, you can always do a disconnect operation. So if I go talk about disconnect operation, it's exactly reverse of the connect operation. What it does, whenever there is an entity, whenever there are for example two faces, let us say they are sharing a common edge. Now you want to disconnect these two faces, so definitely there should be a new edge created at the same location, and that new edge should be assigned to one surface face, and the old edge has to be assigned to the another face. So there should be two distinct edges at the same location, and they should be part of different faces. So disconnect operation does exactly the same thing. What it does is, let me delete this face. For I want to have a real connect operation, so I will delete this face with lower topology, apply, then again move copy operation, this copy it at now 10 because I want to do a real connect operation. So go to edge, say connect edge, so this edge and another edge 8, and say real connect, apply. So I got the, so now this edge is common between the two faces. So face 2, face 1, this edge is common between these two faces. Now if I do a disconnect operation, which is here, so disconnect, now what I can say, I will select this edge, edge 2. What it does is, it creates the new edge at the same location of the same shape, and it assigns that new edge to another face and the old edge to the another face. So if I say apply, if you go to transcript window, it has creating edge dot edge, it has created one new edge, and for that new edge it has also created new vertices. So it, in the sense, while doing a disconnect operation, first thing is it has to create, imagine that it has to create a new edge. So it's up to you, are you going to disconnect the vertices also or not. It means if you say disconnect vertices also, the lower topology also, it also creates the copy. First operation does it creates the copy of this vertex at the same location, it creates the copy of this vertex at the same location, and then it creates the edge using the copy of the vertices that you have created. That is nothing but disconnect edge as well as vertices. But if I say edge only, then what it does is, it does not create the copy of vertices, using the same vertices it creates the edge, a copy of edge. It means, see, if you have two vertices, you can create infinite number of edges in between. So there is only a vertex common in between those two edges, but the edges has nothing to do with each other. So similarly it does the same thing. When you say edge only, it only creates the copy of edge using the same vertices which are present. That is nothing but edge only. Edge plus selected vertex means it will create a copy of edge and a copy of vertex that you have selected. In this case the edge is made up of two vertices, so you can select the vertex which you want to disconnect. So it will create a copy of this vertex 3 only, and then it will create the copy of the edge. So that is what this disconnect operation is. So this is the disconnect operation. You can always go and change the label of the edge. So this is disconnect operation, and this is what edge plus vertices, edge only, edge and vertices. You can always go and change the color of the edge and the label of the edge, but I don't prefer to change the color, because by these are the standard coloring schemes which are there. By looking at them I can understand like whether the geometry is connected or not, so I can have a look at that. So I don't generally prefer to change the color, but I definitely change the label. So I can select this edge, the label of this is edge 8, I can say that is nothing but outlet. So I can recognize that particular edge as outlet. Similarly this edge, I can say this edge is inlet, and apply. So that at the time of applying boundary conditions, I can select the proper edges. So I will say inlet, and then I will put some boundary condition called as, for example, velocity inlet. So I will say some inlet or something. So this is why I want to change the label of the edge. So I can always change the label of the edges. So here if you go modify the color and modify the label. This is the move copy operation which we have seen. You can actually move the entities or copy the entities from one location to another location, and the funda is same. If they are connected to higher topology, you cannot move it, but you can copy it. And there are different operations available like translate, reflect, rotate and scale. Those operations are available. We have seen those operations in general geometry modeling functions. Similarly, I can do a align operation. If the edge is aligned, if edge is inclined to one particular edge, we can always align those two entities, and you can You can also drag those higher topological entities which are connected to edges. If you activate connect geometry, you can also scale the geometry if there is a chance of scaling. So this is nothing but move, copy and align operation, which we already seen.